Dear third prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today. I'm glad to introduce a mathematics lesson. In this video, inshallah, I'm going to explain the whole math lesson for this term. You will find explaining and exciting methods with interesting show, solve many and important problems covering the school book and the exam questions. Finally, you will find here all what you need in these videos. Okay, the first video with us will be Algebra. It's Unit 1, Lesson 1. The lesson is called Cartesian product. In this lesson, first we need to remember the order pair. We already studied the order pair in the first prep and in the second prep. The order pair is a bracket like this, included two numbers, x and y, okay, and forever the first number is x and the second number is y. Okay, the first number is called the first projection and the second number called the second projection. We use this order pair to represent the points on the graph. For example, if we have a graph like this, we see here the horizontal axis called x-axis, okay, and the vertical axis called y-axis. They intersect together at the point 0. Okay, for example, if we have order pair called A and A equal 3 and 4. To represent this order pair on the graph like this, A 3 is the x projection and 4 is the y projection. Okay, we start from 0, 3, then go up to 4. It appears in this position. This is the position of A, which is 3 and 4. Another example, if we have a point B, this point equal 4 and 3. Here x equal 4 and y equal 3. Okay, by representing this point on the graph like this, I'm going to move 4 steps on x-axis and go up 3 units on y-axis in this position. This is the position of B. Okay, by looking carefully to the two ordered pairs, 3 and 4 and 4 and 3, they are not equal because they represented in two different positions. A and B are in two different positions. Then I can say that A and B are not equal. So, if the order is not equal, then the two ordered pairs are not equal. Okay, for example, if we have order pair x and y equal to another order pair 2 and 3. Okay, in this one the first projection is x, and in this one the first projection is 2. Then x and 2 are equal to each other, as we see. Here the second projection is y, and here the second projection is 3. Then y and 3 are equal to each other like this. Then we can form an equations, the first equals the first and the second, and we can find x and y by using the two equations. Okay, let's solve the next example. Example 1 here, find the value of A and B in each of the following. Number 1, here we have A minus 2, B plus 1. This is an order pair. And another one, 2 and the negative 3, another order pair, and they are equal. Okay, here I'm going to divide the page into halves like this. First projection equal to the first projection, then A minus 2 equal 2. Okay, remember with me, how can we solve this equation? I'm going to send the minus 2 there as plus 2, then A equal 2 plus 2 equal 4. This is the value of A. Here the second projection B plus 1, and here the second projection negative 3, then B plus 1 equals to negative 3 plus 1 go there as -1, then it was b equal -3 minus 1, which is equal -4, and this is the value of b. Number 2, here we have a to the power of 2 equal 1 and 1 equal to 36 and b to the power of 5. Okay, I'm going to divide the page into two halves like this. The first will equal the first, a power of 2 equal to 36. Then a power of 2 equal to 36. We studied before in the second prep to cancel power 2, then I'm going to take the square root to both sides, but don't forget negative and positive sign. Then a equal negative or positive square root 36, which is equal 6. Okay, then a here has two values, 6 and -6. The other side, 1 equal to b to the power of 5. Then I can write it as b power 5 equal 1. As we studied before, if we have a power, then the inverse operation of this power is the root. Then I'm going to take the fifth root to both sides. The fifth root of b power 5 equals b, and the fifth root of 1 equals 1. Then here b equal 1 and a equal 6 and -6, the next one. Here we have in this one a minus 7 equal to -2. Okay, then a minus 7 equal -2. Send -7 there as plus 7. Then a equals 5. And b power of 3 minus 1 equal to 26. Okay, first I'm going to send 1 here as plus 1. Then b to the power of 3 equal to 27. And then I'm going to take the cubic root to both sides. Okay, the cubic root hasn't a negative or positive, then I'm going to write b equal 3 like this, and then the value of b equal 3. The next one, here we have 3 and b equal 2a minus 5a minus 1 and 4a. Here we have a repeated in both sides. I will start with the first equation. In the first equation we have 5a minus 1 equals 3. I'm going to send 1 there plus, then 5a equal 4. And then I'm going to send 5, then 4 divided by 5, then a equal 0.8. Okay, here a equals 0.8. Then b equal 4a, then b equal 4 times 0.8, then b equals 3.2. Okay, now we have remembered the meaning of the order pair and the problems about this concept. Okay, now we are going to study another concept which is called the Cartesian product of two finite sets. First, before explaining the Cartesian product of two sets, okay, we will start with this example. In this example, we have group A included a dog and a cat, and group B included chicken and milk. Okay, now we need to multiply group A times group B. The multiply here means distribution. Then the Cartesian product means the distribution. Distribution means what? Means if the dog start with eating the chicken, Okay, this is the first element, dog and chicken. This is product A times B included this element dog and chicken. Okay, the other element, the cat drinks the milk. This is the second element. The third element, the dog drinks the milk. Finally, the cat eats the chicken. Okay, then the Cartesian product means what? The Cartesian product means the distribution. Every element on the group A distributed among every element in group B. Here, the dog eats the chicken and the dog drinks the milk. Also, the cat eats the chicken and the cat drinks the milk. Okay, this is the concept of the Cartesian product of or the distribution of sets. Okay, now we are going to study the Cartesian product about the sets. Let we have a set X included two elements 1 and 2 and a set Y included A, B and C, and Y here included 3 elements. Okay, now to multiply A times B, and I will read it A X product Y. Okay, means distribute every element from X among every element in Y like this. First, 1 will connect with A. It will be 1 and A in order pair, and then 1 distributed among B, then 1 and B. It will be 1 and B in order pair. Okay, and next 1 and C, it will be 1 and C in order pair. Then I'm going to distribute the number 2. Okay, it will be 2 and A in order pair, 2 and B, 2 and C. Okay, look here, every element represented in order pair like this. And finally, we are going to close the set. Here we have in set X included 2 elements, set Y included 3 elements. By counting the number of elements of the product X product Y, here we have 1, 2, 3, 4, 5 and 6, because 2 times 3 equals 6 elements. Okay, then the Cartesian product means distribution of X among Y. Okay, here we have nx. Nx, this symbol means number of elements of X. Here X included 1 and 2. It included 2 elements, as we see, and another symbol ny. Ny here means the number of elements of Y, which is 3 elements. If we need to find nx times y, okay, without writing the Cartesian product, we can use this number 2 times 3 like this. It will be 6. Now we can find the number of elements of the product by 2 different ways: by writing the product and count its brackets or its ordered pairs, and or by multiply the number of elements of X times the number of elements of Y. Now I'm going to learn how can we represent the Cartesian product graphically. First, to represent the Cartesian product graphically, we have 2 ways. The first way called the arrow diagram, and we are going to learn the 2 ways because in the exam he may ask me represent by arrow diagram or by the other way. Okay, the first way, the arrow diagram. Okay, remember with me X equal 1 and 2. Okay, first I'm going to draw a rectangle or oval. Okay, but the rectangle is better. Okay, and I'm going to write the elements of X inside the rectangle like this: 1 and 2. And then I will draw the set y inside a rectangle like this, and I'm going to write the elements of y inside the rectangle like this: A, B, and C. Okay, as I said, this one called arrow diagram. Then every element represented by arrow like this: 1 connected with A with an arrow like this, 1 and B, 1 C, 2 with A, 2B, 2C. Every element represented by an arrow like this, so we called it arrow diagram. Here, by counting the number of arrows, here we have 1, 2, 3, 1, 2, 3. They are 6 arrows, okay, because we have 6 elements inside the Cartesian product x product y. Okay, now I'm going to learn the other representation graphically, which is called the Cartesian diagram or the Cartesian graph. Okay, the Cartesian graph or the Cartesian diagram, we will start with the first set x horizontally like this, and the second set y vertically like this. Okay, and then write the elements of x down and the elements of y up like this. Here we have 1 and 2 inside x, a, b, and c inside y. Every element from every number or every element, we are going to draw a line segment like this. From 1, I'm going to draw line segment, from 2, from A, from B, and from C. Okay, so it's called Cartesian diagram. It also like the x-axis and y-axis as we studied in the first and second prep. Okay, here we have 1 and A, 1 and A connected together with this point, 1 and B, 1C, 2A, 2B, and 2C. Here we have 6 points because we have 6 elements as we studied before in the Cartesian product. Okay, next. Last time we studied how can we multiply or find the product of two sets x and y. Now we are going to learn how can we find the Cartesian product of x times itself, which is called x2. Okay, x2, it's not x power 2, it's x2, which is mean x times x. Okay, or x product x. For example, if x equal 1 and 2, then to find x2, which is mean x times x, then we are going to distribute x among x like this. Here x equal 1 and 2, and the other x equal also 1 and 2. Then I'm going to distribute 1 with 1 like this, 1, 2 like this, 2, 1, 2, and 2. And then finally I'm going to draw the bracket. Okay, now to calculate the number of elements of x2, by counting this one, we have here 1, 2, 3, 4 brackets, or by another way, because we have 2 elements inside x, then we can find it by raise 2 to the power of 2. Because we multiply x times itself, it will be 2 times 2 or 2 power of 2, which is equal 4 elements. Now I'm going to how can represent x2 graphically. Okay, like this. The arrow diagram, the first arrow diagram, if x equal 1 and 2, then x times x, it's not x times y, it's x times x. Okay, x inside the rectangle and the other x inside the rectangle, x equal 1 and 2, the other x equal 1 and 2. Okay, 1 and 1, 1, 2, 2, 1, 2, 2. Okay, and to represent this one by Cartesian diagram, x horizontally here and x, the other x, vertically here. Okay, here we have 1, 2, 1, and 2. And from every element we are going to draw line segment like this. They have 4 intersected points, okay, and I'm going to put the points like this. This is 1, 1, 1, 2, 2, 1, 2, and 2. Now in this case, we have another way to represent the arrow diagram. This is especially for x power 2. Okay, in this kind of representation, we are going to draw a large rectangle like this. And in this rectangle, we are going to write up x2. Okay, now we have inside x, we have 2 elements, 1 and 2. Okay, I'm going to write 1 like this and 2 like this. 2 beside each element, I'm going to put a dot. Now we have 1 from an element from 1 to 1. It will be like this. An arrow go from 1 to 1. Okay, and then from 1 to 2 like this, and from 2 to itself like this, and from 2 to 1 like this. Here we have 4 arrows because we have 4 ordered pairs or 4 elements inside this product. Don't forget this kind of arrow diagram, especially for x2. Okay, now let's solve the next example. In this example, if we have x equal 1 and 2 and y equal 3, 4 and 5, okay, find x product y and then represent. Okay, we are going to take this one step by step. In the first step, I'm going to write x product y. Okay, like this. X product y equal set of 1 product 3, 1 4, and 1 and 5. Okay, 2 and 3, 2 and 4, finally 2 and 5. Okay. He asked me to represent by number 1 arrow diagram. Okay. To represent by arrow diagram, I'm going to draw 2 rectangles like this, x and y. Inside x, I'm going to write 1 and 2 here. And inside y, 3, 4 and 5. Okay, I'm going to 1 3, 1 4, 1 5, 2 3, 2 4 and 2 5, and this is the arrow diagram. Number 2, by graphical diagram or Cartesian diagram. Okay, I'm going to draw a horizontal set x and a vertical set y, and I'm going to write the elements of x and the elements of y, and I'm going to draw the line segments in front of each element like this. Here I'm going to write 1, 2, here 3, 4, and 5. Okay, here 1 and 3, 1, 4, 1, 5, 2, 3, 2, 4, and 2, 5. The next example. Find x product y and represent by arrow diagram and Cartesian diagram. Okay, here we have x times x. Okay, to find x times x, I will write another x above x. Okay, like this, 3, 4, and 8. Okay, I will start 3, 3, 3, 4, 3, 8. X product x equal 3, 3, 3, 4, 3, 8, and 4, 3, 4, 4, 4, 8, 8, 3, 8, 4, 8, 8. And here, by counting the elements or the brackets, 1, 2, 3, 4, 5, 6, 7, 8, and 9, because 3 power of 2 equals 9. Okay. Now I'm going to represent by arrow diagram like this, x product x. In the first one, I'm going to write 1, 2, and 3, and 3. 3, 4, and 8. And here also 3, 4, and 8. Okay, 3, 3, 3, 4, 3, 8. 4, 3, 4, 4, 4, 8. 8, 3, 8, 4, 8, 8. The representation on the arrow diagram in the Cartesian diagram like this. X up and x down, and I'm going to write 3 lines horizontal and 3 lines vertical like this. Okay, here we have 3, 8, and 4, and here also 3, 4, and 8. In front of each, here we have 3, 3, 3, 4, 3, 8, 4, 3, 4, 4, 4, 8, 8, 3, 8, 4, 8, 8, and this is a graphical representation of or the Cartesian diagram of x times x. Another example. Here in example 4, number 1, if x equal 3, then x2. Here x2 means 3 set 3, product set 3, it's included 3, 3, one element only inside a bracket. Number 2, if x equal 1 and 2, y equal 3 and 4, then 3 and 4 belongs to what? Here 3 inside y, here, and 4 also inside y. Then 3 and 4 belongs to y, product y. Again, x included 1 and 2. y included 3 and 4. 3 belongs to y and 4 belongs to y, then 3 and 4 together belongs to y, product y. The next one, if nx equal 4, ny equals 2, then nx product y, it equals 4 times 2, which is 8. Okay, the next one, nx equal 5 and y included 2 elements. Then nx times y, here 5 times 2 equals 10. The next one, number 5, nx equal 3, ny equal 12, then y equal. Okay, we know that nx product y, then 3 times what equal 12. Again, 3 times what equal 12. It's 3 times 4. The next one, if 3 and 5 belongs to set 3 and 6 and set product set x and 8. We know that 3 belongs to the first set and 5 belongs to the second set. Then it must be 5 in this set, then x equal 5. Now we have a revision on sets because completing the next questions. Okay, let we have a set x which equal 1, 2, and 3 and a set y equal 3 and 4. Now we need to remember the operations on sets. Okay, let we have a set U included 1, 2, 3, 4, 5, and 6. U here is called the universal set or set included all the elements of a main subject. Okay, now we need to remember how can we represent this element by a Venn diagram. Here we have x and y included 3 in between. Then we are going to represent x and y by 2 ovals, and there is an intersection area between them like this. X equal 1, 2, and 3, y equal 3 and 4. 3 here is included inside x and inside y. Okay, now we have 5 and 6 are outside x and y. They will be represented like this, outside x and y, because we have finally u included all x and y and 5 and 6. Okay, now we need to remember the operations. The first operation called the intersection, x intersect y, which means the common elements at x and y. It's very clear here that 3 is the element 3 is the common between x and y like this, and don't forget to write the element inside a set. Okay, now x union y means all elements at x or at y. Now I'm going to take all elements inside x or inside y. We have here 1, 2, 3, and 4 like this. Okay, x minus y or x difference y. X difference y means the elements that are at x and not at y. They are 1 and 2 are the 2 elements inside x and not at y like this. And finally y difference x, the elements that at y and not at x, because y minus x, they are the element 4 only. Okay, don't forget to write all the results at sets, because intersection and union and difference are operations on sets. Okay, let's solve the next problem. Here we have in example 5, x equal 1, y equal 2 and 3, z equal 2, 5, and 6. Represent x and y by Venn diagram. then find. Okay, first I'm going to represent x, y, and z in a Venn diagram. X included 1, y and z included a common element 2. Okay, then I'm going to draw a set and a set z and a set y. Here in between we have the element 2, and here we have 3, and inside z we have 2, 5, and 6 there. Then we have 5 and 6 here. Okay, x included 1, and 1 is not common with x or y, then with y and z. Then I'm going to draw x separately here in this position, included 1, and this is the Venn representation of the three sets x and y, x, y, and z. Okay, number 1, find x product y. Okay, x product y, here we have 1 and 2 and 3, 1 and 2 and 1 and 3. It will be like this: 1 and 2, comma, 1 and 3. Next, y product z, it will be 2 and 2, 2 and 5, 2 and 6, 3 and 2, 3 and 5, 3 and 6. Okay, the next one, number 3, x product z. X product z, 1 and 2, 1 and 5, 1 and 6. Okay, the next one, y2, which is y times y. Up over y, I'm going to write here 2 and 3, 2 and 2, 2 and 3, 3 and 2, 3 and 3. It will be like this: 2 and 2, 2 and 3, 3 and 2, 3 and 3. Number 5, here we have x product y union y product z. Here we have x product y here and y product z here. Union, then I'm going to take all the elements without repeated. Okay, don't forget here we haven't any common elements. Then I'm going to write all the brackets. Here we have 1 and 2, 1 and 3, 2 and 2, 2 and 5, 2 and 6, 3 and 2, 3 and 5, finally 3 and 6. Okay, x times y intersect z. X included the element 1. This is x. Product y intersect z. Y intersect z at the element 2. Then I will write 2 here inside a set like this. X, then set 1 product set 2. It will be 1 and 2 only inside a set like this. The next one, number 7, x product y intersect x product z. Here x intersect y included 1 and 2, and x intersect z included 1 and 2, 1 and 5, 1 and 6. Here we have, I see here 1 and 2 and 1 and 2 are common in both sets. Then 1 and 2 is the common element of the two sets. It will be 1 equal 1 and 2, like this, between brackets and between two braces. Number 8, x minus y product x union y equal z minus y. Here z included 2, 5 and 6, and y included 2 and 3. Then z minus y equal 5 and 6. Product x union y. X union y, here x included 1, y included 3 and 2. Then x union y equal 1, 3 and 2. Then it's equal set 5, 1, 5, 3, 5, 2, 6, 1, 6, 3, 6 and 2. Now I'm going to study a new concept called a Cartesian product of infinite sets. We have studied how to multiply two finite sets, for example set x and set y. If set x included 2 elements and y included, for example, 3 elements, then we have already 2 finite sets. But what if we have 2 infinite sets, like n, or the natural number n times n, or z times z, or r times r? Okay, because the most important one is r times r, then I'm going to study only r times r. Okay, here to represent r times r, it's impossible to find the product r times r by write this product inside set, because r is infinite set, included infinite number of sets. And it's impossible also to represent by arrow diagram. Then the only way to represent the product r is by Cartesian product. By Cartesian diagram. In this Cartesian diagram, we represent the first r on a horizontal method, horizontal axis called x-axis, and the other r represent on a vertical straight line called y-axis. Then here x-axis represent the set r, and y-axis represent also the set r. They divided the graph into 4 quarters. Every quarter called quadrant. This one called the first quadrant, and this is the second quadrant, and this is the third quadrant, and this is the fourth quadrant. Okay, now we need to learn how can we find a points inside our order pairs inside this representation of r product r. For example, if we have an order pair 3 and 1. 3 and 1 represented here, this is x and this is y. This, okay, 3 and 1 go like this, 3 and go up to 1 here in this position, as we see. Okay, 3 and 1 lie in the first quadrant, as I said before. Okay, 3 is a positive number, 1 is a positive number, then we can deduce that every point belongs to this quadrant, the two numbers or the two projections are positives. Okay, then we can say that 3 and 1 belongs to the first quadrant. Okay, another example. If we have point like negative 5 and 1, negative 5, go like this, start from 0, go to negative 5 here, and go up to 1 here in this position. Okay, this is the point which represents negative 5 and 1. This one is called the second quadrant. As we see in the second quadrant, the first number is negative, the second number is positive, like this, and this is the rule of the second quadrant, negative, positive. Okay, then we can say that negative 5 and 1 belongs to the second quadrant. Okay, the next one, negative 5, negative 2, it's here, negative 5, down, negative 2, here in this position. This is the third quadrant. Okay, here as we see, x is negative, y is negative, then the two numbers are negatives. This is the rule of the third quadrant, and this is belong, as I said, in the third quadrant. Finally, if we have point 4 and the negative 1, from 0, 4, and go down to negative 1 here in this position, as we see. Okay, this is the fourth quadrant, as I said before. Here in the fourth quadrant, x is positive and y is negative. It will be positive, negative. Don't forget, positive, positive, it's first quadrant. Negative, positive, second. Negative, negative, third. Positive, negative, fourth quadrant. As I said, this is the fourth quadrant, positive and negative. Okay, then 4 and the negative 1 belongs to the fourth quadrant. Don't forget, positive, 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 negative, 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 and positive, negative. Okay, it's a very, very important, this one. Example 6, here we have x equal negative 2 and 3. Here x is an interval, y equals 0 and 4. Find the region which represent each of the following. Number 1, x product y. Okay, now to find this one, I can't find this one as a product because, as we said before, the interval included infinite number of elements inside it from negative 2 to 3. All the numbers starting from negative 2 till 3. Okay, product y, which is 0 and 4. The only way to represent this Cartesian product is the Cartesian diagram. Okay, the Cartesian diagram, as I said before, for the infinite sets, okay, represented by x-axis and y-axis like this. As I said, x here represent the first set represented on the x-axis here from negative 2 till 3. All this region belongs to represent negative 2 and 3. All the elements from negative 2 to 3 represent the first set. Okay, the second set represented on y-axis, it's from 0 to 4 here. It's from 0 here till 4. All this area represented the other set or the other interval like this. They intersect at this square as we see here, okay, or this rectangle. Then the region which represent the solution set, it will be like this, which represent x product y. It's very clear and it's very easy. Okay, the answer here represent only the region. We can't represent it by sets or by interval. It's only graphically representation. Number 2, here we need y product x. Y, which is 0, 4, product x, which is negative 2, and 3. We will represent 0, 4 on x-axis, negative 2 and 3 on y-axis, like this. 0, 4 here, from 0 till 4, all this area represent the first set or the first interval. The other one from negative 3, from negative 2 to 3, okay, from negative 2 to 3 represent the other area, like this. They intersect in this rectangle, as we see, which represent y product x. Example 7. In this example, number 1, x equal 1 and 2, and then x product phi, any set product phi equal phi. Number 2, 5 and 6, comma 5 and 7. This is a Cartesian product because we have set included ordered pairs. Okay, the origin of this product was set, product set. The first set included the first element 5 and 5. Okay, it's only 5 without repeated. The second set included 5 and 7. Okay, 6 and 7, then it will be 6 comma 7. The next one, if x2 equal 1 1 1 2 2 1 2 2, then x equal, x is a set of 1 comma and 2. Don't write here ordered pairs. Number 4, x minus 1 equals 8 and 11 equals y plus 3. Okay, first x minus 1 equal 8, then x equal 9, and y plus 3 equals 11, then y equals 11 minus 3, which is 8. Then x equal 9 and y equal 8, then root x plus 2y equal root 9 plus 2 times 8, which is equal 9 plus 16 equals 25, root 25 equal 5. Okay, the next one, number 5. The point x and 7 lie on y-axis. Okay, remember with me, if we have here the two axes, this is x-axis and this is y-axis. Any point belongs to y-axis is 0 and number. For example, this one 0, and if this one 0 and if this number is 7, then this one is 0 and 7. Okay, then any point belong to y-axis, its x coordinate equal 0, then x here equal 0. Okay, if we have negative 4 and y, negative 4 and y belongs to x-axis. Here negative 4, then y here equal 0 because it belongs to x-axis. Then 2y minus 1 equal 2 times 0 minus 1, it's equal negative 1. Number 7, absolute x and 4 equals 3 and y to the power of 2. Find the point, and the point x and y belong to the second quadrant. Find x plus y. Okay, first, absolute x equals 3. As we took before, if absolute x equal 3, then x equal negative or positive 3. Okay, if y power of 2 equals 4, then y equal root 4, negative or positive root 4, or negative or positive 2. Okay, x plus y, but here we have two values for x and two values for y. Then I'm going to take what? The second quadrant, as I took before, its negative number and positive number. Then x, I'm going to take the negative number of x, which is negative 3, plus from y, I'm going to take the positive number, which is 2. Then x plus y equals negative 3 plus 2, which is negative 1. And this is the end of our first lesson. I hope it was helpful for you. See you in the next video, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.